we're going to do some solving compound inequalities here. So if it's an and inequality, all that really happens, guys, it's like two equations or two inequalities squeezed into one. So you can solve them at the same time. If you really want to, though, you can split them. So what I usually do is just solve them together because it's really this inequality you're solving and then also this inequality. If you prefer, you can rewrite them both separately as 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 15. You guys can solve them separately. I think if you're able to, though, it's just easier to do them both at once. So since you're doing really two inequalities at one time, you're still trying to solve for this variable in the middle of your compound inequality. You're still trying to get x by itself. So the first thing I would do is subtract 5. But because there's really two inequalities here, you're not just doing it to this side and one other. You have to do it to all three sections. So that minus gets it out of the middle. You just bring down your signs. 3 minus 5 is negative 2. 15 minus 5 is 10. And then you just keep going. So you just have to remember you're doing it to actually three places and you're working from the middle out. Still trying to get x by itself, so the last step is going to be to divide by 2. And we get negative 1 is less than x, which is less than 5. So if you guys would have tried to solve them both separately, over here on the right, you should have gotten the same thing. So then the last thing to do is to just put it on the graph. So greater than negative 1, less than or equal to 5. And that's it. And then for the ors, you just literally solve them both separately because ors will always be separated. And can be written separately. So if you see the word and there, it's okay. It just means your solution should shade in the middle still. It's just that sometimes they do choose to write it as two separate inequalities. But ors will always be written as two different ones. And then you just solve them both. So if you solve the first one, subtract 7. And remember, this rules do apply still for these guys when we're dividing by negative. So here we're dividing by negative 2. And we get y, flip our sign, greater than or equal to 3. So if you guys had to flip your signs for an and inequality, up above, you would actually just flip all the signs in the problem. So you don't just flip one of them, all the signs flip because you're dividing everything by that negative. So the first one is greater than or equal to 3. The second one, subtract 10. Get 3y is less than negative 6 minus y. Add y. And we get 4y is less than negative 6. Divide by 4. So y is less than, I'm going to reduce that, negative 3/2, which is negative 1/2. So less than negative 3/2, greater than positive 3. So that's fine. So let's see here. 0, negative 1, negative 2. So greater than or equal to 3. Less than negative 1/2. So that's it. So ands you can solve together. Or you can break them up and solve them separately, or you'll literally just solve them both individually and graph your solution. But ands go in and ors will go out.